Imagine this. You're on a spacewalk outside of the International Space Station. Normally, you'd have to layer up, wearing your temperature-controlled spacesuit. Without it, you'd freeze to death out in the cold vacuum of outer space. But today's a little bit different. Instead of shivering out in space, you're now sweating. That's because space is no longer cold. The temperature has heated up and space is now hot. How could something like this happen? Would our solar system need to add another sun or two? And what would this mean for life back on Earth? This is What If, and here's what would happen if space was hot instead of cold. Okay, quick brain fact. Did you know that curiosity is one of the only emotions that actually rewires your brain in real time? The moment you lean in to understand something, like you are right now, your neurons start building new pathways. When you watch curiosity-fueled content like this, your brain treats it like active learning, decoding and making sense of new ideas just like it does when you solve a puzzle. So, watching our shows is literally good for your brain. Well, that's why we launched the Popular Science Fast channel, where you can stream all our shows 24/7. Tune in any time of day and you'll find mind-bending science from us and from some of the world's leading creators, including NASA's spaceflight, Hacksmith, and Complexly. Plus, live rocket launches, documentaries, and deep dive specials. It's basically a non-stop feed of curiosity, always on, always learning. We're currently available on 10 different platforms, including Vizio, Roku, and Plex, but we're just getting started. We're reaching tens of millions of homes and streaming devices all over the globe, and that audience keeps growing every month. And the channel just keeps evolving. We're adding brand new series and specials monthly, from breakthroughs in tech to space exploration coverage you can watch live. It's a front row seat to the new space race, alongside a 150-year-old legacy of science storytelling now being brought to streaming for the first time. So, if you ever finish one of these streams and still want more, well, you don't have to wait. You can jump straight into Popular Science and keep that curiosity going. It's there 24/7, ready whenever your brain wants its next aha moment. Before we grapple with the cause and effect of our new hot space, let's take a look at what makes space so cold in the first place. Fortunately, the answer to this isn't all that complicated. In the whole of the universe, there's a lot of stuff. Billions of galaxies filled with billions of stars, orbited by billions of planets. But the fact of the matter is, there's a lot of space between these objects. And in this empty space, there just aren't enough particles of matter to hold or transfer heat. That leaves the overall temperature of space somewhere around 2.7 degrees Kelvin. What does that mean exactly? Well, on average, outer space is a frosty minus 270 degrees Celsius, or as Canadians like to call it, January. And it would be even colder throughout the final frontier of space if it weren't for something known as cosmic microwave background radiation. This is radiation that spreads throughout the entire universe. It's a remnant of the earliest moments after the Big Bang. So if everything were to suddenly heat up, well, it wouldn't necessarily mean that our sun has started working overtime. It could mean that the entire universe is changing radically. Okay, now it's time for us to turn up the cosmic thermometer. But how? Well, let's start by generating some of this new interplanetary warmth close to home. If our sun were to increase its power output, that would make things in our own solar system a little toastier. But this wouldn't be a small adjustment by any means. Our sun is powered by nuclear fusion in its core that turns hydrogen into helium. It's been doing this for over 4.5 billion years and should continue to do so for another 4.5 billion. But in order to crank up the heat, we'd need the sun to skip ahead to its next phase of life. As a red giant, this would require it to exhaust its supply of hydrogen, making its core richer and richer in helium. As it does that, you'd find the bright object at the center of our solar system contracting under its own gravity and heating up. It would be burning its dwindling hydrogen supply at a faster rate. And this would cause the sun's outer layer to expand massively. Hence the name Red Giant. Burning brighter and hotter, all this extra energy would radiate throughout our solar system. The only problem is that the near vacuum of space wouldn't magically become a better conductor of heat. There still just wouldn't be enough particles of matter. But for areas where matter is more condensed, around celestial bodies like planets or gas and dust clouds, there things would definitely heat up. But as for Earthlings like yourself, well, this would be bad news. Our globe is already warming, and all this extra heat would tip the scales even more on our climate. It would trigger a runaway greenhouse effect, an absolute point of no return. Our atmosphere would trap more and more of this solar energy, and Earth's surface temperature would skyrocket. This would create a feedback loop of things getting hotter and hotter, boiling our oceans away until the planet is barren and lifeless. Yeah, probably not what you were hoping for when you wanted to increase the temperature of outer space, right? Well, it gets worse. If the sun were a red giant, its outer layers would expand as far as Mars. So, yeah, we'd be completely engulfed by the sun. So that might not be the best option. Let's try a different method for bringing space up to a more comfortable temperature. Let's imagine the possibility of our Milky Way galaxy, which is already made up of somewhere between 100 billion to 400 billion stars, becoming a lot more densely populated. You know, our galaxy is incredibly vast and sparse too. Currently, there are only 0.004 stars per cubic light year of space. If we bumped that number up and doubled the amount of stars in our galaxy, that could have an impact on increasing the temperature of space. And if we made sure that these new stars burn as bright and as hot as blue giants, the impact would become much more pronounced. Blue giants may not be the biggest stars in the universe, but they certainly are giants. They can be anywhere from 3 to 10 times more massive than our sun. And they're hot. They burn a distinctive blue color and have a surface temperature between 10,000 and 50,000 degrees Kelvin. That means they'd be as hot as 50,000 degrees Celsius. At this point, they're pretty much the same. Unfortunately, this wouldn't change the nature of empty space. If we wanted this heat to impact things closer to home, in our own solar system, these massive radiating stars would need to be clustered within a few hundred light years of our planetary neighborhood. But be careful what you wish for. You wouldn't want these stars to be too close. The last thing you'd want as a result of this heating experiment would be to upset the delicate gravitational balance of our solar system. Not only that, but the increased radiation from these hot, bright stars would also have a noticeable impact on life on Earth. For starters, the night sky would undergo a dramatic transformation. These new stars would make everything brighter. As a result, we might lose sight of many other celestial objects. Not to mention there'd be a huge increase in UV radiation hitting Earth that could thin or further damage our atmosphere's ozone layer. This would increase your chances of getting skin cancer. And just like in the first scenario with our exploding sun, it could lead our planet toward a runaway greenhouse effect. Yeah, looks like space might just need to remain cold after all. what you're hearing isn't some roaring space beast. It's the sound of a black hole. And not just any black hole, a supermassive black hole at the center of the Perseus galaxy cluster. I guess you could call it a space beast. It sounds eerie, right? Well, space is a vast and scary place, but it can also produce some beautiful melodies. Today, we're going to show you some of the most mind-blowing and scariest interstellar sounds, including what Earth sounds like. But wait a minute. There is no sound in space, so where does this cosmic music come from? Alright, let's clear something up. The thing about sound is, sound waves need matter to carry the vibrations, but space is a vacuum. If you scream in space, no one hears you, remember? And that's not because you're far away, but because there's just nothing in space to vibrate and carry the sound. So, how do we get a melody like this? Well, this epic space track is the sound of a dying star, specifically an extremely bright and short-lived star named WR124, or simply Wolf-Rayet. This star sits about 28,000 light-years from Earth, and it's about to collapse into a black hole. Yeah, its very hot core will explode into a bright supernova and give life to a shiny new black hole. Now, of course, I don't recommend going too close to a dying star, but if you did get in proximity to Wolf-Rayet, it's not going to sound like that. Scientists created this sound based on the data they collected about the star. They took X-ray data from Chandra, infrared imagery from the James Webb Telescope, Herschel, Spitzer, and WISE, and translated it into this beautiful musical piece. Astronomers call this process sonification. Well, everyone calls this process sonification, but this time it's astronomers doing it. They represented WR124's hot core with an intense, descending, scream-like tone, which personally I find very fitting. Then they added flutes to represent the nebula gases, bells for the stars in the background, and harp notes for the X-ray sources. String chords represent gases expanding into space, and there you have it, the sound of a dying star, about to become a black hole. But not every cosmic melody is born from death. Some are a little stranger, like the sound of this singing comet. Yeah, even comets can produce spooky sounds in space. In 2014, the European Space Agency's Rosetta probe detected a mysterious song coming from Comet 67P. Rosetta's instruments picked up vibrations in the comet's magnetic field, and this is what they heard. These plasma waves have very low frequencies, around 40 millihertz. Now, your ears can't hear a frequency that low, so scientists cranked up the volume on this comet. So now you can hear the eerie, whistle-like song of 67P, the singing comet. Yeah, well, not all space soundtracks are pretty. Just like the soundtrack of Moulin Rouge, most of them are unnerving. Here, let me play you the sound of interstellar space. Yeah, scary, isn't it? This is the sound that we captured outside of our solar system. In August of 1977, a human-made probe, Voyager 2, left Earth and began its journey across the solar system. A couple weeks later, it was followed by Voyager 1. Now, if you're wondering why Voyager 2 started its journey before Voyager 1, well, just know this. Voyager 1 had a shorter trajectory and actually reached Jupiter and Saturn before Voyager 2 did. Anyway, both of these probes captured plasma wave audio recordings as they passed the planets in our cosmic neighborhood. And let me tell you, our solar system sounds unnerving. Here's the sound of Jupiter. Fair warning, it's not the most pleasant of noises. Yeah, if Jupiter was in a band, it'd make your ears bleed. This sound was recorded when Voyager 1 approached the planet and crossed Jupiter's bow shock. That's the boundary between the solar wind and Jupiter's magnetic field. Jupiter's magnetosphere is enormous and intense. This screechy, high-pitched sound is intense plasma wave activity from Jupiter's magnetic field and radiation belts. Now, coming up, we'll play you what Earth sounds like. It's pretty intense, but first, let's see if Uranus sounds any better. What you're hearing now is the sound of dust impacts on Uranus's rings. And this is the music of the Uranian magnetosphere. And this alien noise is Uranus's plasma waves. All these sounds were recorded by Voyager 2 as it did its flyby around Uranus. Now, while this was happening in 2012 and 2013, Voyager 1 left the solar system and became the first human-made object to enter interstellar space. That's when it recorded this unsettling sound. I don't know about you, but to me, interstellar space sounds super spooky. It didn't stop there. No, Voyager 2 went deeper into space. There, it encountered not one, but 3 cosmic tsunami waves. These tsunami waves aren't like tsunamis we have on Earth. These are large-scale ripples in the plasma of space caused by massive solar eruptions. This sound was recorded when coronal mass ejections from the sun slammed into the plasma beyond our solar system. The sun triggered shockwaves that caused interstellar gas to vibrate, and then Voyager's plasma wave sensors detected those vibrations. Now, Voyager 1 and Voyager 2 weren't the only crafts recording plasma waves that scientists would later translate into music, if you can call that music. In 2001, Cassini went on a mission to explore Saturn, and on its way there, this is how it captured Jupiter. Still a little eerie, but not as dramatic as the sound of Jupiter's magnetosphere. I will not play that one for you again. But I will play the sounds of Jupiter's moon, Europa. Space may not have the matter to carry sound waves, but it is full of plasma. The space plasma is charged particles that can vibrate and create electromagnetic waves. The sound of Europa you just listened to is the converted plasma wave vibrations that another spacecraft, Juno, picked up when it came close to this moon. To create these cosmic melodies, scientists look at the frequency of vibrations recorded by probes like Juno. If those frequencies fall near the range that human ears can hear, then they can play them back directly as sound. But if the waves are too low or too high, NASA speeds them up or shifts the pitch into the audible range. That's how we get a lot of these space sounds. Now, NASA's Cassini spacecraft didn't just record Jupiter. This craft orbited Saturn, and it carried a radio and plasma wave science instrument, an RPWS. And with that instrument, Cassini discovered that Saturn emits intense radio waves tied to its auroras. To create this audio, Cassini's team compressed 27 minutes of data into 73 seconds. Because the original frequencies were well above the human hearing range, they shifted the pitch so that you could hear Saturn's roar. Now, this scary noise scientists picked up when the Cassini spacecraft crossed the gap between Saturn and its rings in April of 2017. What you're hearing is ring particles striking the probe. Now, this next creepy soundtrack from space isn't from some alien planet. It's actually the sound of Earth's very own magnetic field. If you've ever wondered what Earth sounds like, well, thanks to the European Space Agency's swarm satellites, now you know. It sounds terrifying. To make this recording, scientists took real magnetic data from deep inside Earth's core and its space environment, then turned it into sound you can hear. Yeah, those low rumbles, creaking metal, and eerie whispers, that's the sound of our own home planet. The most intense parts of this track are based on a real geomagnetic storm triggered by a solar flare back in 2011. That creepy moan you hear is the sun slamming charged particles into our planet's magnetic field. A lot of these sounds are scary. Far and deep into outer space, you could hear two black holes colliding. What you're hearing here are gravitational waves that scientists converted into sounds you can hear. When black holes collide, they cause enormous gravitational waves that create ripples in space-time itself. These specific waves are called GW150914. They were created by two black holes, 36 and 29 times the mass of our Sun. When these two monstrosities merged, they created a larger black hole that was as massive as 62 suns. These waves happened over 1 billion light years away from us, and they were picked up by the LIGO Observatory. You could say that this is the sound of gravity itself. Space is vast and empty, but it's not as empty as you might think. Some regions of space have a lot of hot gas, and I'm not just talking about the region of space here in my studio, if you know what I mean. Anyway, hot gas can actually carry sound. Now, let's go back to our supermassive black hole in the Perseus galaxy cluster. What you're hearing is the black hole shooting pressure waves into the surrounding hot gas. Scientists detected these signals from X-ray data, and these are the actual sounds coming from this black hole. I mean, really, these sound waves are about 57 octaves below what you can physically hear, so NASA cranked up this black hole's groans into something your ears can register. Well, some black holes sound prettier than that. Remember the first ever image of a black hole? Yeah, this one. This is the silhouette of the supermassive black hole M87 star. This gigantic cosmo monster is devouring matter about 55 million light years from Earth, at the center of galaxy Messier 87. Now, of course, we didn't just take a photo of the black hole. This image was created by combining data from 8 radio observatories. In April of 2017, scientists linked 8 radio telescopes from around the world to form the Event Horizon Telescope. These telescopes observed a supermassive black hole, M87 star, and recorded mountains of radio wave data. From there, supercomputers stitched the data together, pixel by pixel, to reveal that glowing orange ring. Then, scientists took it a step further and translated the data into this cosmic song. Remember the Voyager 2 spacecraft? Well, one day it will reach the deepest depths of interstellar space and record the sound of a black hole up close. It's always better to send space probes into space, because if you came dangerously close to a black hole, even for a nanosecond, you'd be spaghettified, turned into human spaghetti. So we all know Chase dies a lot.
Oh no. Yeah, but not today.
Well, today we want to show you the 9 worst ways to die in space.
Wait, what?
Yeah, that's right. We're taking Chase to the most perilous places in space. Some of these will lead to deaths that are pretty gruesome.
Why can't we ever make a video that's the most relaxing places to take vacations in space?
There are 200 billion trillion stars scattered throughout space. While they light up the universe and provide us with the heat needed for life, these balls of gas are extremely lethal. Quite regularly, stars give off intense bursts of radiation and energy known as solar flares. These bursts have so much energy that they strip surrounding planets of their atmosphere and unleash deadly radiation into space. Proxima Centauri is one of the most volatile stars ever discovered. As a red dwarf star, it's small, but it has extraordinarily powerful magnetic fields. These fields frequently clash, triggering intensely violent solar flares. Scientists once reported a solar flare so bright that the star temporarily became 14,000 times brighter than its average state.
Okay, well, nothing's happening now. And you said it was unpredictable, so how do we even know when the next big solar flare is gonna be?
Electrical systems failing. Outer shell burning.
Rico! Reroute auxiliary power to life support systems!
Rerouting to...
Oh no! No, 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 no!
When a sudden surge of high-energy particles hits your spaceship, it would fry every piece of electronics. In a matter of seconds, X-rays and gamma rays would rip through your spaceship, and you'd be suffering from intense radiation poisoning.
Aw, I don't like the sound of that.
With a direct solar flare blast that strong, the radiation would cause severe alterations to your DNA. You'd feel nauseous and incredible weakness, signs of acute radiation poisoning. At the same time, your life support systems would fail and you'd have a hard time breathing. It would take just 5 minutes for radiation to destroy your organs. The good news is you'd likely lose consciousness and die before your ship ran out of oxygen, because suffocating on a damaged ship sounds a lot worse than a nauseating death from radiation.
Okay, this time I'm gonna be flying further away from those radiation-spitting stars.
There are invisible forces at play all throughout the vastness of space. Every star, planet, and moon, everything has a gravitational pull, and if you don't maneuver carefully, you'll end up in a pretty disastrous situation.
Yeah, I'm an experienced space adventurer. I think I can navigate gravity. Besides, I'm on my way to a somewhat familiar place, Kepler 22b. You know, I really gotta give this place a second chance.
That would be Rock's S42BB, a gas giant that's 9 times the mass of Jupiter. And yeah, it's got an incredibly strong gravitational pull.
What? No. Oh no, no. 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 Not again.
The enormous gravitational pull from this massive planet would catch you in the gravity well trap. Gravity well is space around a massive object like this planet that pulls all nearby objects toward it. And it's dangerous. Your ship's thrusters would fail to counteract this gravity. You'd be rapidly pulled toward the gas giant, all the while experiencing some serious G-forces. You and your ship wouldn't stand a chance against Rock's S42BB. The G-forces you'd be feeling would cause you to black out. You'd be falling deeper and deeper into this planet's atmosphere until your ship violently breaks apart. And when your ship does break apart, you'll be flung out into the storm of toxic gases and superheated winds. It'd be brutal.
granted, that landing was not so smooth. But this time, I'm gonna land on purpose, and I will survive.
Landing on planets with an atmosphere is extremely complicated because an atmosphere is full of particles that create intense friction during entry. The intense friction generates enormous heat, and if you're not careful, your spaceship will burn up before reaching the surface. If Kepler 22b had an Earth-like atmosphere, landing there would be tricky. You'd need to carefully maneuver your ship to manage heat and turbulence.
Okay, lock in, Chase, lock in. Just need to do the S-turns. Make sure the broadside of the ship is exposed.
At this point, your spaceship is moving at 28,000 kilometers per hour. The atmosphere of Kepler 22b would create resistance, heating your ship's exterior to a blistering 2,000 degrees Celsius. If your ship's heat shield fails, the cabin would become unbearably hot in seconds.
What? Kepler's supposed to be balmy. This is way too hot.
Intense turbulence would begin to tear your ship apart. This would mean decompression and failure of all life support systems.
But what about auxiliary power? Okay, Kepler. You win. This time. You know what? Of all the planets in the solar system, Earth is actually the only one I haven't died on. I do see why y'all prefer to live there and not on Mars.
Well, Earth is a particularly tough planet to land on. Not only are you navigating its gravitational pull and atmospheric friction, but you also have to dodge a ton of space junk. Literally, there's an estimated 9,000 tons of junk in Earth's orbit, over 100 million bits of small debris, and about 25,000 pieces larger than 10 centimeters. Stuff like old satellites and missile debris get trapped here, some traveling at speeds over 8 kilometers per second. That's 10 times faster than a bullet.
No worries, I got this. Okay.
Yep. Yeah, I knew that was gonna happen. Spacecraft already have to carefully navigate through Earth's low orbit, avoiding debris with tracking and collision avoidance maneuvers, but things may get much worse. If we don't do anything about this debris, it'll keep colliding and breaking into smaller fragments, eventually forming a dense, unmanageable cloud of space junk around Earth. This scenario is known as the Kessler syndrome. And it's bad because it could make it nearly impossible to leave Earth. All spacecraft would face a high risk of collision. Even the tiniest piece of orbital debris traveling at thousands of kilometers per hour could cause catastrophic damage.
This has been a really tough few days. Every time I die, I feel a little less and less like myself, like a shell of a man. I need somewhere that I can go and be away from people and things.
Well, that works out perfectly because your next stop is Triton, one of Neptune's moons. It has no stuff and no people.
Oh, okay, great. Let's go.
Triton is one of the coldest moons in the solar system. Its surface is so icy that it reflects almost all of the sunlight it receives, which is very little to begin with. The surface temperature here is roughly minus 235 degrees Celsius, which makes it the perfect place to freeze to death. Even NASA's most advanced exploration extravehicular mobility unit suits, developed for the Artemis missions to the moon, will only withstand temperatures of minus 173 degrees Celsius. And Triton is a lot colder than that.
What? You sent me here just to die? I'll remember this what if guy.
On Triton, you wouldn't lose heat immediately like you do on Earth. That's because Triton doesn't have an atmosphere, so there's no air to carry away your heat through convection. It would take you some time to die here. Your heart would start slowing down to 30 beats per minute. Blood would no longer be delivering oxygen to your body. You'd be completely numb. It would take about an hour or two for your body to freeze solid.
I'm not dying anymore. No way. I'm done, okay? I'm upgrading the ship so it's gonna protect me from radiation, freezing temperatures, micrometeoroids. It's gonna protect me from everything. Good luck trying to kill me this time, Peter. Ow. Ah! What the?
Oof, that was a micrometeoroid, a tiny piece of debris that can travel at tens of thousands of kilometers per hour. They usually burn up in a planet's atmosphere because of their tiny size, but out in space, they're like bullets. Most astronauts are pretty unlikely to get hit by one, but Chase is an exceptionally unlucky guy.
Rico, open the door! Rico, door, Rico! No, not, Rico!
So, right now, Chase is experiencing ebulism, which is a fancy way to say decompression, which is a fancy way to say that the rapid change in pressure is causing all of the liquids in his body to boil and evaporate. Yeah, this one might be the worst yet.
Okay, that was bad. That was really, really bad. But if I just keep working on the ship, I'll be safe. I'll get it all done, and then I won't get hit by another. Oh, you kidding me? Come on!
Oxygen levels critical.
Oh no.
And that was a huge mistake. In the vacuum of space, there's no air pressure. And your spacesuit just took a hit, which means that the pressure inside it will change and cause the air to expand. That big gulp of air you just took, that's about to explode your lungs in 3, 2, 1. As your lungs get torn from the inside, air bubbles will enter your bloodstream, and that will lead to an embolism that will block blood flow to your vital organs like your heart and your brain. Cue heart attack, stroke, and death. Space is so treacherous that even the safety of a ship, yes, even an upgraded one, can't always protect you. There's not much anyone can do against the invisible threat of a black hole. With gravitational pulls so strong they even suck in light, once you realize you're close to one, it's already too late.
Yeah, and there's probably a black hole right next to me, isn't there? Oh my god, there is one! Oh, Rico, fire all engines! Reverse! Full reverse! Come on, Rico! Auxiliary power, Rico!
All engines in reverse.
Damn it! Peter!
Getting sucked into a black hole, you experience so much gravitational pull, your body literally gets spaghettified. You turn into a long strand of human spaghetti. There was no avoiding that one.
That was brutal, man. I mean, that's almost as bad as the time you killed me off on every single planet in the solar system. Wait. How am I not tied to the spaceship? Hey! Hey! No! No! Rico, if you can hear me, send out the grappling hook right now!
You're out for a routine spacewalk. Suddenly, your helmet comes loose. But instead of suffocating, you breathe in fresh cosmic air. How far-reaching would this space atmosphere be? Why would space suddenly become so loud? And could this lead to the destruction of the whole solar system? This is What If, and here's what would happen if outer space was breathable. The atmosphere you breathe here on Earth consists of 78% nitrogen, 21% oxygen, and trace amounts of other gases. It's that molecular oxygen that is essential for life. Molecular oxygen is rare beyond the 10,000 kilometers that the atmosphere extends above the Earth's surface. In space, oxygen atoms bind with space dust. They react with hydrogen atoms and create water ice instead of molecular oxygen. But what if we could find breathable air all the way to the edges of the heliosphere? That's the boundary where the sun's gravity is no longer as strong as that of other stars. Would an expansive atmosphere mean you could travel anywhere in space and breathe like you do here on Earth? Besides that surprising breath of fresh air, there would be some other big changes you'd hear of. You'd now be able to listen to the sun and the other planets. In the vacuum of space, sound can't travel. That's because there are too few molecules between the planets and the stars to carry the vibrating sound waves. But in this new space atmosphere, those sound waves could travel great distances, so you'd be able to hear everything loud and clear. The sun is constantly vibrating at different frequencies. It would be so loud that it would seem deafening. Even considering the great distance between our star and the Earth's surface, it would still reach your ears at a volume of 125 decibels. Imagine going about your daily routine to a soundtrack similar to church bells. Only it would be as loud as thousands of police sirens. This would be annoying, but it wouldn't be your biggest problem. In the vacuum of space, there's no friction. That means all the planets and moons orbit the sun without losing speed. Or at least losing it very, very slowly. But now, with outer space filled with air, all the planets would be slamming into air particles at very high speeds. The Earth would experience the same fate as the asteroids that enter our planet's atmosphere. The friction causes them to heat up and burn. So, with the Earth currently orbiting the Sun at a velocity of 30 kilometers per second, all that friction would leave us with nothing more than scorched surfaces. And this would be far from the end of the chaos. Eventually, the moon would slow to a complete stop. Yeah, then Earth's gravity would pull the moon closer, and that would result in a devastating collision. If you survived through the scorched Earth, this crash would be the end for the whole planet. It would tear the Earth apart. The rest of the solar system wouldn't fare much better. With so much air in it, our solar system could turn into a black hole. This is because all this air would have mass. And with the radius of the heliosphere spanning 90 astronomical units, that's a lot of mass. Yeah, about 5 billion times more than the Sun itself. So, if the Sun's gravitational pull made all this mass compress toward it, the solar system would become increasingly dense. If all that air compressed into a space about 80% of the Earth's diameter, you'd witness the creation of a black hole. I mean, if you were still alive at that point. That's unlikely. That black hole would be about 1,200 times more massive than the supermassive black hole in the middle of the Milky Way. When you think of ringed planets, well, you probably assume there's only one of them in our solar system, Saturn. But what if I told you that there are 3 other planets similar to Saturn? Yeah, it's true. Jupiter, Uranus, and Neptune all have their own sets of rings. Most people don't know about them because they're much thinner and pretty much invisible from Earth. We only learned about them when Voyager 1 and Voyager 2 flew past them in the 1970s and 80s. Some scientists even think that Earth had rings at some point in its existence. 4.5 billion years ago, when a planet the size of Mars smashed into our young rock, it ejected so much debris that it likely, briefly, formed a small ring around Earth. Despite their unimaginably massive gravitational pull, black holes don't go around sucking in everything in their way. It just doesn't work like that. Black holes are more like sinkholes. If you were to get too close to one, you'd get spaghettified and lost to the blackness of this monstrosity. But if you're far enough away from it, you'd be safe. Even if our sun was replaced in the middle of our solar system by a black hole with similar mass, all the planets would just orbit like nothing happened. Things would get pretty dark, though. Now, speaking of darkness, the moon doesn't have a dark side. Our planetary partner gets hit by the sunlight all around. The reason why you don't see the other side of the moon is because it's always facing away from us. Yeah, our moon rotates on its axis at the same rate it orbits Earth, making it what's called tidally locked to our planet. If a large asteroid is on a deadly collision course with Earth, the best thing to do is to nuke it. Oh, sorry, wait, I've actually got that wrong. Do not nuke asteroids that are about to collide with us. The reason why? Well, because the nuclear explosion will shatter the asteroid into millions of smaller pieces. Yeah, the pieces that would still be headed for impact with us. Instead of dealing with just one giant asteroid, we'd have to deal with multiple impacts. And it would make our evacuation really difficult, or straight up impossible. Now, you still can use a nuke to prevent an asteroid collision, but you don't even have to strike the space rock. We just set off a nuke near the asteroid. Emphasis on near. Then, the force from the blast would nudge it off course. And that would keep our planet safe. Hopefully. Standing on Earth at night, you can see thousands of stars, but the view from the moon is actually quite boring. Yeah, astronauts who traveled to the moon reported that stars aren't easily visible from there. Because our moon is super reflective, it really cranks up the brightness, making it harder to see out to the stars. It's kind of like stargazing in a city with a lot of light pollution. Not fun. You'd need to travel further into space to get some better views. Traveling in space won't make you taller. Though it's true that astronauts can grow up to 5 centimeters in space, well, that's because the Earth's gravity doesn't weigh them down, and the vertebrae in their spines are able to expand a bit. But this effect is only temporary. As soon as you return to Earth, you get back to your regular height. Yeah, thanks, gravity. And space travel doesn't make you age slower either. Not really. Albert Einstein theorized that time would pass slower for someone traveling at high speeds versus for someone stationary. This is called time dilation. And while it's true, you'd have to travel incredibly fast to achieve this de-aging effect, like almost speed of light fast. Yeah, with our current space traveling technology, the difference in time is so minimal that it's not even worth calculating. If you thought crying in space was impossible, well, first, why? And second, you're wrong. It's just different. Without gravity to pull your tears down, they don't trickle down your face like they do here on Earth. The tears just stick to your eyes and form a sort of watery blob. They might even cover your eyes if you cry a lot, so while you can totally cry in space, it's probably best that you don't. Not great for visibility. Hey, Martian dust storms are a real headache. The dust particles are so fine that they can get anywhere, and these dust storms can last for months, but they can't physically damage any equipment that we leave on the red planet. The thing is that the Martian atmosphere is super thin, just about 1% of the atmosphere we have on Earth, so even when these dust particles zoom around at about 100 kilometers per hour, they can't pack a big punch without the help of air. But what they can do is cover our solar panels and put our rovers into power-saving hibernation. Oh, and I wouldn't inhale this dust either. Who knows what this fine powder could do to your lungs long-term? Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, this song is a big fat lie. Yeah, despite the famous children's song, stars don't twinkle. The flickering is just an illusion. Their light is actually very steady. Stars appear to twinkle due to the gas molecules that make up our atmosphere. They deflect some of the light from stars, making them appear as if they're shimmering. Asteroid belts are typically depicted as minefields of floating rocks. Spaceships have to weave in and out of the asteroids in a life-or-death situation, but in reality, our asteroid belts are nothing like what you see in the movies. Asteroids aren't that close together. In fact, they're extremely far apart. For example, in the asteroid belt between Jupiter and Mars, each of the asteroids is several million kilometers away from their nearest neighbor. And the chances of a collision are about 1 in 1 billion. So while Han, Chewie, and Leia had you on the edge of your seat in The Empire Strikes Back, asteroid fields like that are far from reality. The Great Wall of China is known to be the only man-made object that's visible from space. But this is entirely false. Yeah, sure, maybe you could see it with a camera and a zoom lens, but it's almost invisible to the naked eye. At 5 to 10 meters wide, the wall is way too thin to be seen from space. However, you can still see plenty of other man-made objects from space. Things like dams, bridges, and pyramids. And at night, you can see a light show from the world's big cities. A nuclear bomb is the most dangerous weapon we have on Earth, and thousands of them are spread across the world. Just one of these bombs has the power to wipe out an entire city, so what would happen if all of them launched at once? And instead of their targets being here on Earth, they were headed for space. Why would this be a good thing? How dangerous would these nukes be? And how far away would they need to travel to keep us safe? This is What If, and here's what would happen if all nukes exploded in space. Okay, before we send all these bombs out into orbit, let's take a closer look at what we're dealing with. First of all, we're not talking about 1 or 2 or even 100 nukes. Latest estimates put the total number of weapons of mass destruction scattered around the globe at approximately 12,705. And it should come as no surprise that they aren't evenly distributed among world powers. Of course, the US and Russia are in the lead by no small number. Between these two historic rivals, they have over 11,000 nuclear warheads. The remaining nuke-possessing countries like China, France, Pakistan, and India have no more than a measly couple hundred. But even some of these smaller nuclear devices could annihilate whole cities, wipe out thousands, if not millions of people, and bring our entire planet to the brink of destruction. So it's finally time to band together and finally get these bombs off of Earth. If we can. We live in an age where sending rockets into space feels like it happens almost every day. But shepherding thousands of nukes off of Earth is a bit more of a dangerous payload than SpaceX is used to handling. This effort would require a plan of action unlike anything before. Let's start with security. Sure, a scenario aiming to remove nuclear weapons and promote world peace is nice to imagine, but let's be real. Handing over nuclear weapons for disposal would be no simple task. Besides, who would be the trustworthy candidates to carry out the job? Nuclear weapons programs have extremely strict security protocols. No one individual has the ability to arm or launch weapons alone. And with peace on the horizon, now would be no time to change that. Clearly, a trusted international organization with a commitment to transparency would need to be created just for this project. It would be staffed by world governments, scientists, and the brightest minds Earth has to offer. Security would need to be as tight as ever, though, because there could be criminal organizations interested in taking advantage of this situation to gain a unique amount of power in a future without nukes, or at least without thousands of them. But let's skip ahead to the more out-of-this-world aspects of this scenario. Launching thousands of nukes would require new rockets to be built specifically for handling radioactive cargo. In the case of a leak or damage, they would need to be guaranteed without a doubt that they would exit our atmosphere safely. These rockets would need all the same durability and heat-resistant technology as space shuttles. Plus, they'd need to be more powerful and be able to carry more cargo than ever before. Nukes can weigh thousands of kilograms, and our current rockets aren't carrying those kinds of cargo loads, so we'd need to compensate for that. Each weapon would need to be individually housed in a shock-resistant containment vessel. And these would need to be able to withstand various disaster scenarios, in case the launch fails. One of the most dangerous aspects of this whole mission would be that these warheads would need to be detonation ready before they leave the ground. If just one nuke or rocket malfunctions, it's game over for Earth. To be extra safe, the neutral organization overseeing this launch would need to build a brand new launch site specifically for this mission. And it would make sense that this site would be far, far away from highly populated regions of the world, to avoid worst-case scenarios. So, once we start launching these nukes, where would they go? Well, keep in mind that the International Space Station is orbiting Earth at over 400 kilometers above sea level, so we'd need to make sure that the rockets would speed well beyond this point. The last thing we'd want to do is to send any astronauts stationed there to the most explosive death possible. Now, if we did detonate the nukes too close to Earth, a whole mess of things could happen. Now, down on the ground, you'd be fine. Since space has no atmosphere, the explosion wouldn't produce the typical blast wave or mushroom-shaped cloud that we're used to seeing. You'd still see an explosion, but it wouldn't be nearly as violent, and the radiation would be too far away for it to harm Earth. But that doesn't mean nothing bad would happen. If the nukes were to detonate in our satellite orbit, we'd notice that right away. The explosions would create all kinds of space debris that would destroy satellites. This would threaten our communications, information, and navigation systems around the world. Not to mention, the nukes could create an electromagnetic pulse over various countries, knocking out our power grids and cell phone towers. Despite this being an attempt at world peace, it could push the world into chaos. Now, what if we tried detonating the nukes a little further from Earth? The safest bet would be to set the detonation zone at or beyond the Moon's orbit, about 384,000 kilometers away. As long as we don't hit our biggest satellite, this would be the best way to minimize the effects of this explosion back on Earth. Okay, finally, it's time for the new Big Bang. Staring out at the night sky, you'd first be treated to a sequence of brilliant flashes, almost like distant stars spontaneously combusting all at once. But you wouldn't see all 12,000 explosions at the same time. We'd time it to be a long series of blasts, spread out over weeks or months to ensure the safest, most controlled conditions. From Earth, the view would be mesmerizing. People all over the world would gather together to celebrate and watch the distant radioactive fireworks. And the flash of the explosions wouldn't be the only visual phenomenon you'd be treated to. All that energy released in these nuclear blasts would create new auroras to decorate our night sky all over the planet. These auroras would be useful to scientists who could analyze an abundance of data on the interaction between radiation and the Earth's magnetic field. If all goes well and the last explosion goes off without a hitch, it'd be time to celebrate a new era in modern human history. Ever since the first atomic bomb was created in 1945, we've lived on a planet loaded with weapons, capable of destroying all life on Earth. Not anymore. But that doesn't mean the consequences of this master plan wouldn't be potentially dangerous in the long run. All this new debris and radiation traveling further out into space could create disturbances well beyond our planet that we wouldn't even have conceived of. Maybe some future interplanetary astronauts will encounter dangerous clouds of radiation that will threaten their lives and the success of their mission. So, although disposing of our nuclear weapons in space could potentially benefit Earth, we'd have to be aware of the downsides that could unfold. Maybe it would be best if these nukes were detonated in a specific spot out in space. One far away from Earth. Buckle your seatbelts, we're about to take a ride on the cosmic superhighway. What exactly are these celestial autobahns? How would they help us explore the furthest parts of our solar system? And could they change our approach to mapping the cosmos forever? This is What If, and here's what would happen if we built a highway in space. I know what you're thinking, and no, we aren't talking about laying down pavement to build some kind of outer space freeway, though there is at least one Tesla that would be happy about the idea. The space pathways we're talking about are called space manifolds. These are arch-like structures that emerge from the complicated gravitational pull between the sun, planets, and their moons. If you found yourself on one of these many interplanetary jet streams, Could you effortlessly cruise our solar system? Or could one wrong turn slam you headfirst into Jupiter? We've built highways all over Earth, and the only thing you need to get started on your journey would be a roadmap. When it comes to space, navigating would be a little more complicated, but you could save a lot on fuel. That's because you'd be utilizing the concept of gravity assist. This is a reliable technique that is already vital to space exploration. If you were on a spacecraft using gravity assist, you could travel much further than your launch vehicle could, launch you. Imagine using the sun and planets like a slingshot to propel yourself around the solar system. You'd add or subtract momentum by increasing or decreasing the energy of your orbit. These techniques have been applied on previous missions like Voyager 2. This outer planet probe was launched in 1977 and got a trajectory boost from the gravitational pulls of both Saturn and Uranus. And now, it's still speeding through interstellar space after more than 40 years of service. But navigating the cosmic superhighway system would be a little more complicated than using the gravity of just one planet. These pathways are generated from the complex gravitational interactions between all the planets, their moons, and the sun. And for starters, they're nearly invisible. If you could spot them, you'd be looking at a network of tubes swirling along with the planets. But just because they're hard to see doesn't mean you couldn't try. It would be important to familiarize yourself with Lagrange points. For any two-body system, like the Earth and the Moon or the Sun and Jupiter, there are 5 locations in space where gravitational forces between the two are in equilibrium, or simply balanced. If you could place your spacecraft on one of these points, then you'd be able to remain in a stable orbit. No need to worry about being pushed further into space or being pulled in to crash. And since all two-body systems have these points, that means our solar system is full of them. As planets orbit the sun, these points overlap and intersect, so if you're paying attention, you could time things just right to jump off to another planet's orbit. Hopping through space on these superhighways would allow you to save a lot of money on fuel while reaching the outermost parts of the solar system at breakneck speeds. If you found yourself on the right route, you could travel the 3.7 billion kilometers from Jupiter to Neptune in less than 10 years. But I hope you've got a few years or even decades to spare just waiting for these points to overlap in a good way. And you're still going to need a ship big enough for all the cargo you'd be carrying. NASA has estimated that crew of 4 on a 3-year mission would need to take more than 10,800 kilograms of food. But if you could use this cosmic highway, trips that usually take hundreds of thousands of years could be reduced to several decades. Even though scientists have utilized these manifolds on previous missions, it's unlikely they'll be trying crewed missions anytime soon. To truly understand the complex map of connections, we'd need to study many of the millions of objects floating through space, like comets and asteroids. Right? You wouldn't want to smash into the surface of Jupiter if your calculations didn't add up. And this kind of studying could help detect potentially dangerous space objects hurtling along the celestial autobahn straight towards Earth. Now what? I mean, the Earth is gone, and not only are you stuck on the space station above it, there's not a single soul left with you. You are all by yourself, in space, and you have nowhere to go. How long would your supplies last? And what would you do when those supplies are finished? This is What If? And here's what would happen if you were the last human stranded in space. The International Space Station. the one and only research facility orbiting the Earth every half hour. And now, it's your forever home. Unless you prefer living on Mars, but more on that later. The ISS is equipped with laboratories, living areas, a gym, an unimaginably expensive toilet, and it has a supply of food. Not the worst place to be stranded, but you might change your mind about that. Don't start to panic. Just take a deep breath. It's 7 a.m. and you wake up after your 8-hour sleep. You make yourself a protein-filled breakfast and get to work. This space station isn't going to repair itself. You carry on conducting repairs and then you might exercise for a couple of hours. Everything seems normal until you remember that what you saw yesterday wasn't a dream. You try to open a line of communication with Earth to see if anyone's still down there. No luck. You're alone. And you can't go back to what's left of Earth. You can't talk to anyone. Nothing. And you need to start dealing with it. The first thing you'd want to do is see how much food is left. A team of 6 people could last on the ISS for about 3 months. Since you were left all by yourself, you could easily do fine for 18 months or more. But you need to plan your rations. 2 meals a day is a good start. And you could grow fresh veggies right on the space station to keep you going longer. You'd keep recycling and reusing the water. This water was always cleaner than the water on Earth anyway. For the bathroom, you'd keep using a suction tube to pee into. And this waste container is for number 2. It's equipped with a small suction pump so that everything goes in the right direction. No auto flush and no seat heater. So much for the $19 million toilet. While you're floating around with the sweat pooling around your body instead of evaporating, think of this. You'd never take a shower again. I mean a good running water shower. Those would be gone together with the Earth. You'd have to get by squirting a bit of water on your skin and shampooing with no-rinse shampoo. Whether your planet is destroyed or not, your body is built for living on the ground and not in the microgravity environment. On the ISS, your bones would keep losing calcium and your muscles would keep losing mass. This is because in the weightlessness, your body doesn't need bones or muscles much. If you want to keep those, you'd need to hit the gym. Astronauts work out as much as 4 hours in every 16-hour period. There's not much of a gym on the ISS, but at least you can use the treadmill and a sort of mechanical bicycle. And after a long day of working, exercising, peeing in a tube, eating dehydrated food, and trying to stay sane, you'd head back to your sleeping pod and just try to sleep a little. You could live your day-to-day space life all by yourself for a year or 2. Your body would be getting weaker, and the shock and grief of losing everyone you knew would be overwhelming you. The thought of never being able to go back to Earth could cause anxiety, panic attacks, and depression. The total isolation would impact your ability to survive on the ISS. And without proper maintenance, the space station would plunge uncontrollably down to what's left of Earth and splash into the ocean. But what if, instead of giving up and slowly waiting for your end on this enormous craft, you could make good use of it? I'm talking about moving the entire station away from Earth's leftovers. The ISS was built for the lower Earth orbit, but if you had enough fuel in the tank, could you try to use it as a spaceship and accelerate it all the way to Mars? What have you got to lose anyway? You know, I'd really like to give you some emotional support. You are the last person in all of humanity, and you're watching What If. That's just wow. But the truth is, you wouldn't make it to Mars. The ISS is designed for lower Earth orbit. It just wouldn't work for the Red Planet, or for our moon for that matter. Plus, you wouldn't survive very long in the harsh space radiation. And the ISS itself is getting too old to handle space travel. It just wouldn't work. Unless you happen to get stranded on a next-generation space station that required fewer repairs and spacewalks, that would be fully self-sustaining and free-flying. Then you'd call it an early retirement and keep living on it till your life comes to an end. Deadly solar flares, planet-destroying asteroid strikes, or a hostile alien takeover. These might be what comes to mind when you think of the most dangerous threats to Earth from outer space, but the biggest threat could be microscopically small. Why is NASA so worried about space microbes? How much damage could an extraterrestrial microorganism do here on Earth? And if we aren't careful, how would we wipe out life on other planets? This is What If, and here's what would happen if the next pandemic came from space. There are somewhere between 100 and 200 billion galaxies in the observable universe. While we haven't discovered life on another planet just yet, there is a staggering number of worlds where it could exist if the conditions were just right. And that's why NASA and other space agencies take the potential contamination between our world and other planets very seriously. I mean, after all, the last thing we want to do is discover life among the stars, only to find that we put it there. Scientists call this forward contamination. Terrestrial microscopic organisms from our world could arrive on other planets, moons, or asteroids by catching a ride on equipment that someone didn't clean thoroughly. If it's a mission to Mars or Jupiter's moon Europa, where conditions for life are theoretically possible, contamination protocols get even stricter. But another form of contamination is possible: backward contamination. We could unknowingly bring back extraterrestrial microbes from space. Or these life forms could spread across the universe naturally, hitching rides on meteoroids, comets, or even space dust. This theory, known as panspermia, might even explain how life traveled the universe and arrived on Earth in the first place. But where life can go, it can also destroy. When Elon Musk sent his Tesla into space, it's likely he wasn't taking the best protection measures against interplanetary contamination. And as more and more commercial space launches happen, that could become the norm. The reality is that it would be nearly impossible not to contaminate space. It's already too late. Take, for example, a privately launched Israeli lunar lander that crashed on the moon in 2019. It was carrying thousands of microscopic organisms called tardigrades. They are known to be able to withstand extreme conditions like freezing temperatures and high radiation. They could be up there on the moon plotting their revenge right now. Some microorganisms can grow and evolve in microgravity or in conditions similar to the Martian permafrost. That means we need to take every precaution to avoid forward contamination. And before you ask me what any of this has to do with destroying life on Earth, well, just wait. Things are about to get dangerous. But first, how do we avoid this forward contamination? Well, we should start with rigorous chemical cleaning and heat sterilization to kill any life on the outside of our spaceships. Just make sure you step far away from this process. And as we envision human-crewed missions to Mars, we should set up strict policies about where we can land and explore long before we go there. We should establish exploration zones where we could contaminate in a controlled manner. Then we'd apply stricter precautionary measures before we explored other parts of the Red Planet. But it's not forward contamination that should scare you. In these outer space missions, we could accidentally pick up extraterrestrial life and bring it back to Earth. These microbes entering our biosphere could pose existential threats to all kinds of organisms, ourselves included. Finding life on Mars, either fossilized or alive, seems pretty slim, but it's possible that life forms could survive in the water-rich spots on the planet. These Martian organisms may have the same biological origin as life on Earth. Now that sounds cool, but that's what would make them dangerous. Because it's more likely that these extraterrestrial microbes would find Earth to be a hospitable new home. If this was the case, there's a chance that these invasive space microbes might slowly take over our blue marble. They could force many species of plants and animals into extinction. Humans too. And that's because they could be pathogens. Those are organisms like parasites, fungi, or viruses, and they need a host to do their thing. A host like you. And because these parasites are out of this world, they could be resistant to your immune system's responses. They'd quietly replicate and spread inside your body until they were ready to come out. One day you'd cough up a yellow mucus. Maybe an oxygen-loving mucus that would start growing and spreading all around you. This alien monstrosity could grow as fast as 1 meter in one day. Soon, it might develop a fruiting body with deadly spores inside of it. Eventually, this thing would burst open, releasing thousands of spores. Now, this would be one thing if it happened in an isolated lab, but if this monstrosity exploded outside in the open, well, there's nothing we could do to stop alien spores from spreading and infecting everything in their way. That's game over for Earth. Better to eradicate these microbes quickly before they could wipe us out. And that's why we need strict rules and protocols for returning spacecraft, their crew, and any potential biological samples they may carry. In past Apollo missions, astronauts were quarantined for 30 days after returning to Earth, and all the lunar samples they brought were subjected to extensive life detection and biohazard protocols. If you were transporting samples from Mars, well, you should assume they're dangerous until it's clear they're not. That means proper containment. And that containment should stay intact throughout your spacecraft's travel, re-entry into Earth's atmosphere, and delivery to quarantine facilities. You should only distribute the samples once scientists have proven that they don't contain any biological life. If there's even a slight uncertainty that the samples weren't properly contained, well, they and the entire spacecraft must be sterilized while still in space. And if there's still doubt, well, sorry, your spaceship could never return to Earth. The Earth may not be our home forever. Eventually, we may have to leave. What if, instead of finding a potentially habitable exoplanet light years away, we stayed in our solar system and built a habitat so enormous we could never overpopulate it? This is What If, and here's what would happen if we built a Ringworld in space. Imagine you lived on a ring with a radius of 150 million kilometers encircling the sun. A gigantic artificial world with its own gravity, ecosystem, and atmosphere, big enough for trillions of humans to call home. You'd live on an enormous landmass on the inner side of the ring. The outer shell would protect you and all those trillions of people from the hazards of outer space. How does that sound? Yeah, great. Problem is, assembling such a thing suspended out in the solar system wouldn't be easy. You couldn't just pull the Earth apart and have an army of robots reassemble it into a Ringworld. Among the many problems you'd run into, your first would be finding the material. The International Space Station, roaming the Earth's lower orbit right now, weighs about 420 tons. Something like a Ringworld would tip the scales at no less than 1,000,000 tons. Where would we find all this material? I know some places. The Kuiper Belt beyond the orbit of Neptune would do just fine. This ring of icy bodies stretches out for almost 3 billion kilometers. Some astronomers think the Kuiper Belt would have enough material for this project, but it's hard to tell exactly how much we'd need to construct a thing like this. We might have to sacrifice all the planets, moons, and asteroids in the solar system. Our Ringworld and the Sun would be the only things left. If we could manage to gather and transport all the material available, then construction would begin. It would take a lot of physical labor, an army of robots, and maybe hundreds of generations to realize that our structure was not stable enough. Because the megastructure would turn out so enormous, it would break any known molecular bonds. We'd have to find a way to make use of one of the fundamental forces of nature, the strong nuclear force. Of all forces, it's the grippiest. It bonds material on the scale of atomic nucleus so that nothing can break it apart. Or maybe we'd come up with a new, super strong material altogether. But until we figure that out, every interstellar body passing through our solar system would be a threat to our megastructure. The next thing we'd have to worry about is gravity. And that part is pretty easy. We'd just have to spin the Ringworld at nearly 2 million kilometers per hour. I know, that's really fast. We'd have to build up that speed over time. Luckily, maintaining it in the frictionless environment of space wouldn't be too hard. Such rotation would generate centrifugal force, and that, in turn, would create an artificial gravity equal to the one we have here on Earth. With gravity solved, we'd bring in the atmosphere and start populating the Ringworld. For the inhabitants of the megastructure, it would always be daytime, unless we could create a day and night cycle with extra panels inside the ring. But for all the epicness of the world we just created, it wouldn't be stable. A single asteroid strike could cause the structure to drift closer to the sun. A hole punched through the ring could let all our atmosphere out. And a massive solar storm? Don't even get me started on that one. One failure inside the ring could doom the entire structure together with its inhabitants. It's just too risky to build it around the sun. We might have better luck with a huge ring space station in the Earth's orbit. If you were exposed to the harsh depths of space, you'd lose consciousness in 15 seconds and be dead within 30 seconds to a minute. But what if you're wearing an advanced, powerful spacesuit? Well, that would buy you about 6 hours before your oxygen runs out, and then you'd still be dead. So what would happen to your body in space? Would someone come to retrieve it? Or would it just keep floating through space forever? This is What If. And here's what would happen if you died in space. The human race has only lost 18 people in more than 50 years of space exploration. But with upcoming plans for civilian space travel and journeys to Mars, odds are that we're going to be seeing a lot more space deaths. How would we hold a funeral in zero gravity? And what complications would be involved? Every time astronauts launch into space, death is a genuine possibility. They are essentially strapping themselves to giant rockets after all. But because astronauts have to be in top-notch health for a mission, the odds of one of them dying on the International Space Station are pretty low. So low that NASA doesn't even have an official policy for how to handle the situation. According to former astronaut Chris Hadfield, it would be up to the commander of the ISS to decide what to do. The first problem at hand would be that there's nowhere to store the body. Space stations don't come with built-in morgues. One solution would be to keep the body in a pressurized suit and move it somewhere cold. Dead bodies are biohazards, so you'd want to keep the bacteria as far away and contained as possible. But what if you don't like the idea of sharing your quarters with a stiff? Well, there are other solutions. In 2005, a Swedish company proposed a system that essentially freeze-dries bodies and breaks them up into tiny pieces of frozen tissue, kind of like a cremation. This would take up far less space, eliminate the whole biohazard threat, and allow for an easier return to Earth. If you don't happen to have any liquid nitrogen aboard the ship to do the freezing, the ice-cold temperature of space will do the trick. Actually, now that we mention it, Could the most obvious solution have been staring us in the face the whole time? Sailors used to bury their dead at sea. So couldn't astronauts do the same and send their dead off into space? Theoretically, yes, but space is a little more complicated than the sea. Unless you strapped a mini rocket to the deceased, they would end up following the trajectory of the spacecraft from which they were ejected. And if you did that with more than one person, it would make for an unpleasant journey when you decided to turn back home. Okay, so maybe that's not the best option. So what if we waited until we reached our destination? We bury people on Earth, so surely we can do the same on other planets, right? Well, the digging would be a little different, but that wouldn't be our biggest problem. Human bodies, especially the non-living variety, are full of earthly microbes and bacteria that would contaminate any potentially habitable locale. Even the spacecrafts exploring Mars have to be repeatedly cleaned and sanitized to protect the alien planet from earthly bugs. So the only surefire way to safely dispose of a body there would be through cremation. I hope this hasn't ruined the majesty of space travel for you, but it's a reality we have to consider as we move further into the age of space exploration. It might be the worst date on your weekly calendar, but it's a date you definitely don't want to stand up. Garbage Day. You tie it all up into neat plastic bags, haul it outside, and, like magic, your home smells fresh again, and that makes you happy. Yeah, we believe in the magical world of trash. Out of sight, out of mind. But really, we just hide it all in places like this. Did you know the world produces 1.2 billion tons of waste every year? By the year 2100, we'll be producing 3.6 billion tons of waste. How much longer can we rely on landfills? What if we need more space? How much would it cost? What kind of infrastructure would we need? And what could go wrong? This is What If, and here's what would happen if we sent our junk to space. We've got a lot of junk on this planet, and it's only getting worse. So shooting our trash into space sounds like an easy, obvious solution. After all, we've been going into space since the 1950s. Surely now it's easier than ever. Yeah, it's possible. We can shoot our garbage into space, but it certainly wouldn't be easy. The operation would be astronomically expensive, requiring millions of rocket launches every year, which would not only be damaging to the global environment, but could also hinder future space travel. And all this is assuming that things go according to plan. Since the start of the space age, 5,038 rockets have been launched into space. We've sent probes as far as Neptune, and in 2018, NASA sent a probe on a course to the outer atmosphere of the Sun. So in theory, the solar system is at our disposal, for our disposal. But how would it work? An Ariane 5 rocket carries a payload of up to 7,000 kilograms to a stable point in Earth's orbit. It can do this at a cost of around $200 million. But since the world produces 1.2 trillion kilograms of trash per year, we'd need to launch about 168 million Ariane 5s every year to keep the globe garbage-free. And all this would cost, only about $33 quadrillion per year. We'd all have to tighten our belts if we want to make this work. Since worldwide GDP is $77 trillion, we're a bit short. But we're not just short on cash, we're short on resources. 91 orbital rockets were launched in 2017, which might sound like a lot, but it's nothing compared to the 168 million launches we'd have to accommodate. The bottom line, if we want to send our garbage into the cosmos, we'll need to start building a lot more spaceports, a lot more launch pads, and we've got to do it fast. But suppose we somehow found a way to supply the infrastructure and foot the bill. There are some things we can't control. Russia's Soyuz space launch system is the most successful of all time. Its success rate is a stunning 97% for every 1,000 launches. Now, apply that percentage to 170 million launches when each rocket is carrying more than 7,000 kilograms of garbage. That 3% failure rate isn't so reassuring anymore, is it? A few freak accidents a year could have a devastating impact on our atmosphere, our oceans, and our soil. Not to mention the fatalities and damages that would occur when burning plastics and heavy metal are raining from the sky. And what if a failed rocket was carrying nuclear waste into space? What if accidents and emissions from this space waste program made our world uninhabitable? Would we be beyond saving? In 1978, NASA scientist Donald J. Kessler theorized that the accumulation of space debris over time could become so dense that we could no longer use satellites, or for that matter, leave Earth's orbit. we would be trapped in a toxic world, surrounded by our own garbage, and we would decay as well. We don't like to think about where our garbage goes, we're just glad to see it disappear. But of course, we can't really make it disappear, and we can't just shoot it into space and hope it floats away. Because what if it comes back? What would that look like? Ever since the first astronaut went to space almost 60 years ago, over 500 people have blasted out of Earth's atmosphere. They lived and worked in space at different times, but nobody's ever been born there. What if you were the first space baby to be carried aboard a space station? How would your young body develop in microgravity? And would you be able to visit your relatives on planet Earth? This is What If, and here's what would happen if you were born on a space station. So what's so different about being born in space anyway? No gravity? Well, in fact, gravity on the International Space Station is about 90% as strong as it is on the surface of the Earth. So why do we see astronauts floating around inside it? That's because they're actually falling. Let me explain. Earth's gravity is pulling the ISS down, but the ISS is moving very fast, at the same speed that the Earth's surface is turning underneath it. The space station is constantly falling to Earth, but will never hit it. The freefall is what causes microgravity, making the astronauts float around. So what would it be like to be born weightless? Before we get to the birth part, let us just say nobody's ever had sexual intercourse on a space station, let alone made a baby. It wouldn't be any kind of out-of-this-world experience. Fluids work differently in microgravity. You may not have the blood flow to get you or your partner aroused. Sweat would build up around your body, making it wet and sticky all over. And that's if you could figure out how not to push your partner away upon contact. Conceiving a child would be a whole other problem. In addition to a low-gravity environment, there's also so much radiation in space that it can affect a man's sperm count, possibly even cause infertility. And we don't even know exactly what kind of changes space conditions would cause to a human embryo. Let's imagine your pregnant mother arrived on a space station to give birth to you. The trip to space alone would be hard enough on your mother. Pushing you out of her body without the help of gravity wouldn't be a piece of cake either. If you made it out of the womb, a low-gravity environment would affect your body systems as you grew up, including your muscular development and eyesight. When grown-up astronauts work aboard the space station, their bone density depletes at a rate of 1% per month. Because it takes no effort to float in space, they also tend to lose muscle strength. Now, since there's no way to force a baby to run on a treadmill to keep its muscles forming, as you grew on the space station, your skeleton might become deformed. Your heart would be weak, as it's never had to work against Earth's gravity. Then there's space radiation. It would increase the probability of cancer, dysfunction of the heart and central nervous system, and eyesight problems. If, after surviving all that, you made the trip to Earth, you wouldn't be able to walk or balance properly. You might also struggle trying to interact with people on Earth, since you grew up crammed into a very small space your whole life. Until somebody invents a gravity polarizer to generate artificial gravity fields on a space station, we probably shouldn't think about having babies in space. But once they do, how long do you think it would take for us to become a galactic civilization? That's a question for another What If. Imagine this. You're on a spacewalk outside of the International Space Station. Normally, you'd have to layer up, wearing your temperature-controlled spacesuit. Without it, you'd freeze to death out in the cold vacuum of outer space. But today's a little bit different. Instead of shivering out in space, you're now sweating. That's because space is no longer cold. The temperature has heated up and space is now hot. How could something like this happen? Would our solar system need to add another sun or two? And what would this mean for life back on Earth? This is What If, and here's what would happen if space was hot instead of cold. Okay. Quick brain fact, did you know that curiosity is one of the only emotions that actually rewires your brain in real time? The moment you lean in to understand something, like you are right now, your neurons start building new pathways. When you watch curiosity-fueled content like this, Your brain treats it like active learning, decoding and making sense of new ideas just like it does when you solve a puzzle. So, watching our shows is literally good for your brain. Well, that's why we launched the Popular Science Fast channel, where you can stream all our shows 24/7. Tune in any time of day and you'll find mind-bending science from us and from some of the world's leading creators, including NASA's spaceflight, Hacksmith, and Complexly. Plus, live rocket launches, documentaries, and deep dive specials. It's basically a non-stop feed of curiosity, always on, always learning. We're currently available on 10 different platforms, including Vizio, Roku, and Plex, but we're just getting started. We're reaching tens of millions of homes and streaming devices all over the globe, and that audience keeps growing every month. And the channel just keeps evolving. We're adding brand new series and specials monthly, from breakthroughs in tech to space exploration coverage you can watch live. It's a front row seat to the new space race, alongside a 150-year-old legacy of science storytelling, now being brought to streaming for the first time. So, if you ever finish one of these streams and still want more, well, you don't have to wait. You can jump straight into Popular Science and keep that curiosity going. It's there 24/7, ready whenever your brain wants its next aha moment. Before we grapple with the cause and effect of our new hot space, let's take a look at what makes space so cold in the first place. Fortunately, the answer to this isn't all that complicated. In the whole of the universe, there's a lot of stuff. Billions of galaxies filled with billions of stars, orbited by billions of planets. But the fact of the matter is, there's a lot of space between these objects. And in this empty space, there just aren't enough particles of matter to hold or transfer heat. That leaves the overall temperature of space somewhere around 2.7 degrees Kelvin. What does that mean exactly? Well, on average, outer space is a frosty minus 270 degrees Celsius, or as Canadians like to call it, January. And it would be even colder throughout the final frontier of space if it weren't for something known as cosmic microwave background radiation. This is radiation that spreads throughout the entire universe. It's a remnant of the earliest moments after the Big Bang. So if everything were to suddenly heat up, well, it wouldn't necessarily mean that our sun has started working overtime. It could mean that the entire universe is changing radically. Okay, now it's time for us to turn up the cosmic thermometer. But how? Well, let's start by generating some of this new interplanetary warmth close to home. If our sun were to increase its power output, that would make things in our own solar system a little toastier. But this wouldn't be a small adjustment by any means. Our sun is powered by nuclear fusion in its core that turns hydrogen into helium. It's been doing this for over 4.5 billion years and should continue to do so for another 4.5 billion. But in order to crank up the heat, we'd need the sun to skip ahead to its next phase of life. As a red giant, this would require it to exhaust its supply of hydrogen, making its core richer and richer in helium. As it does that, you'd find the bright object at the center of our solar system contracting under its own gravity and heating up. It would be burning its dwindling hydrogen supply at a faster rate. And this would cause the sun's outer layer to expand massively. Hence the name Red Giant. Burning brighter and hotter, all this extra energy would radiate throughout our solar system. The only problem is that the near vacuum of space wouldn't magically become a better conductor of heat. There still just wouldn't be enough particles of matter. But for areas where matter is more condensed, around celestial bodies like planets or gas and dust clouds, there things would definitely heat up. But as for Earthlings like yourself, well, this would be bad news. our globe is already warming, and all this extra heat would tip the scales even more on our climate. It would trigger a runaway greenhouse effect, an absolute point of no return. Our atmosphere would trap more and more of this solar energy, and Earth's surface temperature would skyrocket. This would create a feedback loop of things getting hotter and hotter, boiling our oceans away until the planet is barren and lifeless. Yeah, probably not what you were hoping for when you wanted to increase the temperature of outer space, right? Well, it gets worse. If the sun were a red giant, its outer layers would expand as far as Mars. So, yeah, we'd be completely engulfed by the sun. So that might not be the best option. Let's try a different method for bringing space up to a more comfortable temperature. Let's imagine the possibility of our Milky Way galaxy, which is already made up of somewhere between 100 billion to 400 billion stars, becoming a lot more densely populated. You know, our galaxy is incredibly vast and sparse too. Currently, there are only 0.004 stars per cubic light year of space. If we bumped that number up and doubled the amount of stars in our galaxy, that could have an impact on increasing the temperature of space. And if we made sure that these new stars burn as bright and as hot as blue giants, the impact would become much more pronounced. Blue giants may not be the biggest stars in the universe, but they certainly are giants. They can be anywhere from 3 to 10 times more massive than our sun. And they're hot. They burn a distinctive blue color and have a surface temperature between 10,000 and 50,000 degrees Kelvin. That means they'd be as hot as 50,000 degrees Celsius. At this point, they're pretty much the same. Unfortunately, this wouldn't change the nature of empty space. If we wanted this heat to impact things closer to home, in our own solar system, these massive radiating stars would need to be clustered within a few hundred light years of our planetary neighborhood. But be careful what you wish for. You wouldn't want these stars to be too close. The last thing you'd want as a result of this heating experiment would be to upset the delicate gravitational balance of our solar system. Not only that, but the increased radiation from these hot, bright stars would also have a noticeable impact on life on Earth. For starters, the night sky would undergo a dramatic transformation. These new stars would make everything brighter. As a result, we might lose sight of many other celestial objects. Not to mention there'd be a huge increase in UV radiation hitting Earth that could thin or further damage our atmosphere's ozone layer. This would increase your chances of getting skin cancer. And just like in the first scenario with our exploding sun, it could lead our planet toward a runaway greenhouse effect. Yeah, looks like space might just need to remain cold after all. What you're hearing isn't some roaring space beast. It's the sound of a black hole. And not just any black hole, a supermassive black hole at the center of the Perseus galaxy cluster. I guess you could call it a space beast. It sounds eerie, right? Well, space is a vast and scary place, but it can also produce some beautiful melodies. Today, we're going to show you some of the most mind-blowing and scariest interstellar sounds, including what Earth sounds like. But wait a minute. There is no sound in space, so where does this cosmic music come from? Alright, let's clear something up. The thing about sound is, Sound waves need matter to carry the vibrations, but space is a vacuum. If you scream in space, no one hears you, remember? And that's not because you're far away, but because there's just nothing in space to vibrate and carry the sound. So, how do we get a melody like this? Well, this epic space track is the sound of a dying star. Specifically, an extremely bright and short-lived star named WR124, or simply Wolf-Rayet. This star sits about 28,000 light-years from Earth, and it's about to collapse into a black hole. Yeah, its very hot core will explode into a bright supernova and give life to a shiny new black hole. Now, of course, I don't recommend going too close to a dying star, but if you did get in proximity to Wolf-Rayet, it's not going to sound like that. Scientists created this sound based on the data they collected about the star. They took X-ray data from Chandra, infrared imagery from the James Webb Telescope, Herschel, Spitzer, and WISE, and translated it into this beautiful musical piece. Astronomers call this process sonification. Well, everyone calls this process sonification, but this time it's astronomers doing it. They represented WR124's hot core with an intense, descending, scream-like tone, which personally I find very fitting. Then they added flutes to represent the nebula gases, bells for the stars in the background, and harp notes for the X-ray sources. String chords represent gases expanding into space, and there you have it, the sound of a dying star, about to become a black hole. But not every cosmic melody is born from death. Some are a little stranger, like the sound of this singing comet. Yeah, even comets can produce spooky sounds in space. In 2014, the European Space Agency's Rosetta probe detected a mysterious song coming from Comet 67P. Rosetta's instruments picked up vibrations in the comet's magnetic field, and this is what they heard. These plasma waves have very low frequencies, around 40 millihertz. Now, your ears can't hear a frequency that low, so scientists cranked up the volume on this comet. So now you can hear the eerie, whistle-like song of 67P, the singing comet. Yeah, well, not all space soundtracks are pretty. Just like the soundtrack of Moulin Rouge, most of them are unnerving. Here, let me play you the sound of interstellar space. Yeah, scary, isn't it? This is the sound that we captured outside of our solar system. In August of 1977, a human-made probe, Voyager 2, left Earth and began its journey across the solar system. A couple weeks later, it was followed by Voyager 1. Now, if you're wondering why Voyager 2 started its journey before Voyager 1, well, just know this. Voyager 1 had a shorter trajectory and actually reached Jupiter and Saturn before Voyager 2 did. Anyway, both of these probes captured plasma wave audio recordings as they passed the planets in our cosmic neighborhood. And let me tell you, our solar system sounds unnerving. Here's the sound of Jupiter. Fair warning, it's not the most pleasant of noises. Yeah, if Jupiter was in a band, it'd make your ears bleed. This sound was recorded when Voyager 1 approached the planet and crossed Jupiter's bow shock. That's the boundary between the solar wind and Jupiter's magnetic field. Jupiter's magnetosphere is enormous and intense. This screechy, high-pitched sound is intense plasma wave activity from Jupiter's magnetic field and radiation belts. Now, coming up, we'll play you what Earth sounds like. It's pretty intense, but first, let's see if Uranus sounds any better. What you're hearing now is the sound of dust impacts on Uranus's rings. And this is the music of the Uranian magnetosphere. And this alien noise is Uranus's plasma waves. All these sounds were recorded by Voyager 2 as it did its flyby around Uranus. Now, while this was happening in 2012 and 2013, Voyager 1 left the solar system and became the first human-made object to enter interstellar space. That's when it recorded this unsettling sound. I don't know about you, but to me, interstellar space sounds super spooky. It didn't stop there. No, Voyager 2 went deeper into space. There, it encountered not one, but 3 cosmic tsunami waves. These tsunami waves aren't like tsunamis we have on Earth. These are large-scale ripples in the plasma of space caused by massive solar eruptions. This sound was recorded when coronal mass ejections from the sun slammed into the plasma beyond our solar system. The sun triggered shockwaves that caused interstellar gas to vibrate, and then Voyager's plasma wave sensors detected those vibrations. Now, Voyager 1 and Voyager 2 weren't the only crafts recording plasma waves that scientists would later translate into music, if you can call that music. In 2001, Cassini went on a mission to explore Saturn, and on its way there, this is how it captured Jupiter. Still a little eerie, but not as dramatic as the sound of Jupiter's magnetosphere. I will not play that one for you again. But I will play the sounds of Jupiter's moon, Europa. Space may not have the matter to carry sound waves, but it is full of plasma. The space plasma is charged